Okay, let's dive into this fascinating new explainer unpacking exactly how large language models handle complex, multi-hop communication. If you've been following AI news lately, you know that multi-agent systems are, well, they're the absolute new frontier. We're seeing them literally everywhere, from autonomous coding assistants writing and reviewing their own software to customer service pipelines that route your issue through like 5 different AI brains before finally giving you an answer. But a really groundbreaking paper just dropped called Faithful, Not Corrective. Message format effects in multi-hop agent relays are tier-dependent, and it fundamentally challenges some of our biggest assumptions about how these agents should actually be talking to each other.
So we're looking at a critical question for pipeline architects today. As data passes sequentially from one AI agent to the next, does the way we format that message actually protect the information? Like, when one agent hands off data, does wrapping it all up in strict JSON or maybe just leaving it as natural language actually make a difference over several hops? We're essentially testing what happens when AI plays a high-stakes, highly technical game of telephone. Think about it. If you whisper a complex story down a line of 10 people, the details get completely mangled, right? Well, does that same thing happen to AI? And can the way we package the data prevent that decay?
At the heart of all this research is a huge conflict dividing the AI community right now. Basically, you've got two active research tracks making completely opposite claims. On one side, there's the format optimization camp. These folks say structured outputs, like JSON, are the holy grail. They drastically cut token costs, they make parsing super easy, and they do it all without hurting accuracy. But on the flip side, you have the format restriction camp. They argue that forcing these rigid schemas actually ruins the AI's natural generation capabilities, making the model robotic and way less capable of deep reasoning. But here's the crazy part. Neither side was really testing what happens when pure copy fidelity is the main goal. Just keeping the facts straight across multiple hops, rather than just asking a model to generate a creative one-shot response.
Which brings us to part one, testing the 6-hop relay. Let's see how they set this up. To finally settle this debate, the researchers built a highly rigorous, controlled testbed. Their goal was to isolate and just observe what happens when pure copy fidelity is the primary directive. They started by generating 12 specific atomic facts. Now, an atomic fact is basically a simple, undeniable piece of data that you really can't misinterpret. Something like the sky is blue or the user's email is johndoe@gmail. They took these 12 facts and passed them through 6 sequential agent handoffs. And at the very end of this digital telephone chain, a highly capable grading model checks the final output against the original truth. They basically built a forensic tracking system to see exactly where, why, and how our data breaks down in transit. To get the full picture, they tested 5 distinct message formats: free natural language, precision instructed natural language, JSON, triples, and key value pairs. But here is the really brilliant part of their methodology. They ran these formats across 2 entirely different capability tiers of AI. They used a strong tier, which represents those massive state-of-the-art models we usually interact with online, and then they used a weak 1.5 billion parameter tier. Why use a weak model? Because that represents the smaller, cost-optimized models you typically find running locally on edge devices, mobile phones, or just deep within really budget-constrained enterprise pipelines. It's this dual-tier approach that really uncovers the nuanced truth here.
And the first big revelation? It's honestly kind of a shocker. If your relay model is strong enough, that dreaded telephone game collapse simply doesn't happen. Under faithful relay instructions, a high-capacity model will preserve those original atomic facts across all 5 formats without any significant degradation, all the way to hop number 6. So the formatting debate basically becomes entirely moot if you just throw a massive amount of compute at the problem. The format fades into irrelevance because the model has the sheer brainpower to extract and pass on the truth, totally regardless of how it's packaged. Moving on to part 2, beware the weakest link. Because let's be real, as developers, we don't always use massive, expensive models for every single step of a multi-agent pipeline. And when we introduce those weaker 1.5 billion parameter edge models into the chain, things get incredibly chaotic. Look at this staggering 8.7 times jump in the performance spread across formats. When strong models were used, the variance between formats was just 2.3 points, basically a rounding error. But when you sub in weak models, that spread violently expands to 20.5 points of variance. Weak models totally expose the fragility of our formatting assumptions. If you're a pipeline architect, this is the kind of variance that literally keeps you up at night, because it means your system's reliability is swinging wildly based purely on whether you decided to use JSON or free text for one specific microservice. So what's causing this? Well, this massive divergence is driven by an epic, invisible tug-of-war happening inside the smaller AI. It's a battle between the encoding toll and drift resistance. To put it simply, think of the encoding toll as the brainpower an AI wastes just trying to remember strict formatting rules. If a small model has to constantly stress about where to place the right brackets and commas for a rigid schema, it quite literally uses up its cognitive budget and forgets the actual atomic facts it was supposed to relay. On the flip side, we have drift resistance. Think of this as the guardrails that keep a model from wandering off topic. Fixed key JSON schemas act kind of like a fill-in-the-blank worksheet, which stabilizes the model's focus way better than open-ended text when it starts to struggle. And fascinatingly, this dynamic tug-of-war actually flips the format rankings mid-chain, depending on which of these two forces overwhelms the model first.
This quote really hits the nail on the head. Pipeline architects cannot optimize for the strongest model in the chain. The weakest link dictates the viable format space. In other words, your pipeline is only as strong and your chosen format is only as viable as the cheapest, smallest agent operating anywhere in that sequence. Format selection isn't about finding a universal best practice. It is strictly a capacity matching problem.
All right, part 3, faithful but not corrective. Now, we have to tackle a massive myth in the developer community. The deeply held assumption that highly structured formats automatically filter out hallucinations or data corruption. The researchers tested this by purposefully injecting a completely wrong value mid-chain, just to see if the structure would catch it. The results? Incredibly stark. That injected error persisted all the way to the final hop in 83 to 100% of the chains, and that was across every single format tested. The retention rate of a blatant lie closely matched the retention rate for the actual true values. The takeaway here is absolutely crucial. Structure is just a vessel. It is not a truth filter. It does absolutely nothing to purge mistakes from your pipeline.
However, structure isn't entirely useless when errors pop up. It doesn't act as a magical error correcting code, but it does provide what researchers call an error localizing channel. Think of it like a medical quarantine. If one specific fact gets corrupted, the rigid structure of something like JSON isolates that infection. It creates a strict boundary, which thankfully means the corruption doesn't cause collateral damage and bleed into all the neighboring uncorrupted facts. So no, it can't cure the bad data, but it absolutely stops the spread. And, if you try to get clever and force higher fidelity by demanding per-hop verification, basically adding cognitive load by asking the AI to double-check its work at every single step, you are going to absolutely wreck your budget. You'll pay a massive 24 to 53% penalty in generation costs, computing time, and token usage for virtually zero improvement in actual accuracy. The fidelity gain was statistically negligible, hovering right around plus or minus 1.8 points. Ultimately, you're paying up to a 53% tax on your compute budget for zero factual gain. You're paying for the overhead without buying the result.
Finally, part 4, upgrading your agent pipelines. Let's make this practical.
Okay, let's take all this theoretical AI research and turn it into highly actionable advice for anyone building these systems today. Here is your new playbook. First things first, audit your weakest relay immediately. If any hop in your pipeline uses a model under 3 billion parameters, drop rigid triple or key value formats entirely. The encoding toll is just way too high for those smaller brains to handle. Second, use strict JSON strategically. Deploy it only when semantic drift is your main threat. Third, please stop relying on your message format to magically correct AI hallucinations. If you need accuracy, you have to build explicit validation steps or external fact-checking tools into the pipeline itself. And lastly, only budget for that heavy verification overhead if strict regulatory rules demand a paper trail, because it definitely won't buy you better accuracy.
Now, ultimately, there is a simpler, albeit, much more expensive, way out of this whole headache. If your infrastructure budget allows for it, simply routing your complex multi-hop passes through strong top-tier models makes the entire formatting debate totally irrelevant. Prefer strong relays for those segments. When the relay has sufficient context windows and massive instruction-following capacity, it becomes lossless. The format fades beautifully into the background, and it lets you get back to focusing on building the actual application. So after seeing how easily errors can survive the multi-hop gauntlet and how weaker edge models can literally buckle under the weight of strict schemas they were never meant to handle, I want to leave you with this final thought to inspire an audit of your own software architectures. How much blind trust are you currently placing in your JSON schemas? Are they actually protecting your data, or are they just heavily taxing your weakest agents? Thanks so much for joining me for this explainer of the source material. I highly encourage you to review your pipelines with these findings in mind. See you next time.